Okay, good afternoon, ladies and gentlemen. This is Professor David J. Reyes. Okay, for this afternoon, I will be discussing a problem. Okay, it's a request of one of my viewers who are watching my DC Circuit long video topic. He gave me a problem and he would like that I will show him how to solve the problem that he would like he had given me. Okay, the viewer is actually from, I will try to read his name. He is from Sri Lanka. The name is Manu Werakudi. Okay, so actually he emailed me and he showed me the diagram and he wanted me to answer the three questions regarding the problem. If I could do it, okay, let's try to solve the problem. The given problem emailed to me by Mr. What do you call this? Werakodi from Sri Lanka is this one. The given figure, I just changed the orientation. I do it vertically. What he had given me is that the power supplies are actually in the inverted portion. So for us to visualize more, I reorient the given figure, but it's the same. The given figure are this one. We are given three voltage sources. This is 2, 4, and 6 volts. The loads are actually 3 ohms, 6 ohms, and 9 ohms. This is lit point P on the circuit diagram, and this is point Q on the circuit diagram. This is point B and point A. Actually, the problem of Mr. Werakudi is actually the voltage across this. Okay. He wants to know the voltage across point B in A with this given problem. Actually, I1 in I sub 2, I just placed that one as a part of the solution. It was not given by Mr. Werakudi. To simplify the writing, I now place I1 in I sub 2, okay? That is a part of my solution. But actually, this is not given and this is not given from Mr. Werakudi. I just placed this one, I1 and I2. Okay, let's try to bring out what is being asked by Mr. Werakudi. I summarized the question, I shorten it, but it is still the same question. Requirement number 1 from Mr. Werakudi is that calculate the voltage at points, this should be points. Points B, or point B, relative to point A. He is asking the voltage if this is point B and this is point A. Mr. Werakudi is asking what will be the voltage across this. Oh, that's an easy one, right? It is just that the points B and A are not connected for the meantime. So just visualize that they are connected by using a voltmeter. That's why he is asking for the voltage reading across this point here in this point. That's the first requirement. Second question. A voltmeter with an internal resistance of 100 ohms is connected between points A and B. Calculate the reading now. Meaning to say, he is still asking for the voltage. Like what he said, he uses a voltmeter, he put it here, the internal resistance is 100 ohms, and he is asking what will be the voltage reading may be. Actually, before we will proceed with the solution, I could answer B and C now, immediately, but I would like to present first the third question. Is it the correct way to measure the voltage between points A and B? Justify your answer. So it seems this is what you call this, this could be a qualifying exam maybe. I don't know where he got this one, you know. This could be a part of a board exam maybe, or anything yet under circuitry. Okay, before I will present the voltage across B, because I will be presenting two solutions, the solutions are actually same. I will answer letter B. Mr. Veracudi place a voltmeter here with an internal resistance of 100 ohms, and he is asking what will be the reading. There is a problem here because it seems Mr. Veracudi don't know the specification of multitesters. Multitesters are actually designed in which the internal resistance should have no effect on the reading that will come out. And from the value he had given me, 100 ohms, this is wrong. This is too small. Because if this is too small, it got an effect on the voltage reading across this. And if you try to Google the specifications of multitesters, the internal resistance of multitesters are actually in the range 10 million ohms for the reading not to have effect on the voltage reading. So I will not answer this one because the internal resistance he had given me is too low. It has an effect, so I will not answer it. If it is 10 million ohms, of course the reading on B should be the same as for A. Whatever the reading we calculate on A, it will be the same because it has no effect. Okay? But since the internal resistance he had given me is too low, it has an effect. Of course, the reading will be different. And I would not like to accept that that the internal resistance is just 100 ohms. It should be in the range 10 million ohms for it to have no effect. And if it had no effect, okay, the reading on B should be same as in A. Okay. Letter C, is it the correct way to measure the voltage between points A and B? Justify your answer. Of course, it's the correct way, right? Whatever voltmeter you will be using here, you could interchange actually the polarity. It doesn't matter because in DC there is a polarity thing, right? So if you put the two terminals here, that's the correct way, right? So I have answered letter C already. Okay, let's proceed with the first question. What will be the voltage across B with the given specification? He told me that he is afraid that he will use the Kirchoff's voltage and current law. He said in his explanation that he's afraid to use it because points B and A are actually open. Okay, for you not to be afraid, okay, for the meantime, connect this one. So you could use the Kirchoff's laws, voltage and current law. For the meantime, try to reconnect it. There's nothing wrong with it. Okay? If you try to reconnect it, of course, by using your Kirchoff's voltage and current laws, we could compute for I sub 1 and we could compute for I sub 2. And after the computation of I sub 1 and I sub 2, we can open this one now. Okay? We mark the voltage across this as simply, this is B, this is A, as B sub BA. Okay? So after the computation of I1 and I sub 2, try to open it again, then try to use again Kirchoff's voltage laws to compute for B sub BA. But in the meantime, like what I said, okay, don't be afraid to close this one. I think that's the trick of the problem. Close it, then try to compute for I sub 1 and I sub 2 using Kirchoff's voltage law. Okay, let's try to bring out the solution. Solution, connect A and B meantime. We connect it, right? Then consider I1 loop. This I1 here, that's my marking. I consider the loop on the left, the current circulating to be I1, and the right loop, I place the designation I sub 2 as the current circulating on the right loop. So actually, for the meantime, there are two unknown currents. And we must have to produce two equations and two unknowns to compute for I sub 1 and I sub 2 using Kirchoff's voltage law or KVL. So considering the I1 loop, the left loop, we cover the right loop. Sorry for this one. What's this one? I got it check. Economy class, Clark. We cover the right loop. So just take the summation of the voltages considering the I1 loop. So I place it there. Considering the I1 loop, take the summation of the voltages and they should be equal to 0. And that's actually Kirchoff's voltage law. Okay? I place it here. Plus 4. Considering this one, it's a voltage source, right? It's a plus 4. There's a drop here. Minus open quantity. The current passing through the 6 ohm load here is actually, if we try to consider the I1 loop, I1 will be a plus and I2 is minus because it's against the direction of I1. So the current passing through the 6 ohm will be the difference I1 minus I2. Okay? That's the voltage drop across this. There are two currents passing here. It's the difference between I1 and I2. Okay? And the voltage drop across here, it will be the current passing through the 3O, okay, which is I1, multiplied by 3. Okay, I think I missed something here. I missed 1. This is minus 2. The polarity of this double source here, considering I1 loop, this is from plus to minus, so this is a minus, and this should be equal to 0. So if we try to simplify this one, 4 minus 2 will be 2. Minus I sub 1 times 6 will be minus 6 I sub 1. Right? This is minus 3 I sub 1. So minus 6 minus 3 will be 9 I sub 1. And this will now be, I sub 2 will now be plus because this is minus minus. So plus I sub 2 multiplied by 6, and this should be equal to 0. Trying to compute for I sub 1, this is linear algebra. I1 now will be 6 I sub 2 plus 2 over 9. We transpose this one to the right, then we divide both sides by 9. So I1 will be 6 I sub 2 plus 2 over 9. And we call this equation number 1. Okay? Considering the I2 loop. So if we try to consider the I2 loop, forget for the meantime the I1 loop. But consider the current passing through it. Okay? We start with this one, plus 6. Okay? The current passing through this 9 ohm load here is just a single current. It is just I sub 2, right? So this is a voltage drop minus I sub 2 multiplied by 9. And the current passing the 6 ohm load, there will be two currents. It will be the difference of I sub 2 minus I sub 1 multiplied by 6. So this is I sub 2 minus I sub 1 multiplied by 6. Right? There are two currents passing here. It's a difference of I sub 2 minus I sub 1 multiplied by 6. That's the voltage drop. See. Minus 4. Okay? And this should be equal to 0. Okay? So if we try to simplify this one, 6 minus 4 will be 2. This is 9 I sub 2. This is minus 6 I sub 2. That will be minus 15 I sub 2. This is a minus I1. That it will become plus I1 multiplied by 6. And this should be equal to 0. Again, computing for I sub 1. We transpose this one to the right. No. Yeah, to the right. So this will now be a plus. Right? We transpose this to the right, it will be minus 6 I sub 1 remains on the left. So to compute for I sub 1, we divide all terms by 6. So this is all over 6. So I sub 1 now will be 15 I sub 2 minus 2 over 6. And that will be equation number 2. So this is now two equations and two unknowns involving I1 and I sub 2. We will be using we equate equation number 1 and number 2. So equation 1, this is equation 2. And if we try to simplify this one, I won't go with the H step. I will just give you the answer now. I sub 2 will be the ratio 30/99, and this is 0.303 amperes. So this I sub 1 here is 0.303 amperes. Okay? By using equation number 1, we could compute for I sub 1. Oh, that's I sub 2, right? Sorry for this one. This should be 0.303 amperes. Not this one. That's I sub 1. Well, compute first for I sub 1. We know I sub 2, using equation number 1, we could compute for I sub 1. I sub 1 will be 0.4242 amperes. So I sub 1 will be 0.4242 amperes. I1 is bigger than I sub 2. Okay? Since this is plus and this is plus, our assumed direction of the currents are actually correct. So to compute now for the voltage across B and A, okay? We now know the circulating current, right? So we open this one now. This is point B, this is point A, and if we try to place our voltmeter here, what will be the reading? Oh, that's an easy one now. Again, by using the Kirchoff's voltage laws, we could present two solutions. Okay? If we try to use the right-hand loop, is it the right-hand loop? Yeah, right-hand loop. This one. We know the circulating current. Mr. Werakod is asking for the voltage across B and A. So we open it, we place the voltmeter. What will be the voltmeter reading? We could do that one now by using Kirchoff's voltage law. So if we try to simplify the right-hand loop, the configuration will be this. Right? The current passing through the 9 ohm load is just pure I sub 2. And that is actually 0.1212 amperes. Right? And the current passing through the 6 ohm load, I1 is bigger than I sub 2. So the current passing here will be the difference 0.4242 minus 0.303, and that will be what you call this I sub 2 is 0.303. This is 0.303. Okay? I sub 6 ohm, this should be 0.1212. The difference of I sub 1 minus I sub 2. I sub 1 is bigger than I sub 2. Okay? This is upwards, this is downwards. So the net current passing here will be the bigger minus the smaller. And the direction should be upwards. Okay? Upwards. This is upward also. Okay, let's try to take the summation of the voltages, and they should be equal to 0. Kirchoff's voltage laws. We start with the 6 volts. So 6 volts is a plus. Minus the drop here. It's 0.303 multiplied by 9. Okay? It's a drop. The drop across the 6 ohm load here, it's not a drop. It should be a voltage rise. Why? Because this current here is against this one, right? So this is 0.1212 multiplied by 6. Okay? That's the reason why this is plus. Okay? This current is against this one, so if this is minus, this should be plus. Okay? Minus the drop across this 4 volts here. The polarity is from plus to minus, that should be minus 4. Okay? Then the problem now is the voltage from point B to point A, so we designate that as simply B sub BA. That's the one being asked by Mr. Werakod. Right? So this is minus capital letter B with the subscript BA, and they should be equal to 0. And if we try to simplify this one, what will come out, okay, is actually B sub BA is equal to 0. It's 0. And to check the validity of this one, okay, we will be using again the left-hand loop. Okay? we know the circulating current. This is B sub BA, but for the meantime, when we try to take the summation of the voltages, it will be from A to B, but later on, we will just reverse it so we could compute for B sub BA. So, this is the left-hand loop. I'm still on camera. 6 ohms, this is 3 ohms, 2 volt, 4 volt, right? The current passing through the 6 ohm load is 0.121 amperes. And the current passing through the 3 ohm load, this one, it's the total value of I sub 1, which is 0.4242. Taking the summation of voltages again, plus 4, okay, minus the plus is plus, this is a drop. So this is minus 0.1212 times 6. 0.4242 goes with 0.1212, so it's the voltage series is still a voltage drop. It's not the voltage rise. So this is minus 0.4242 times 3. Minus 2 volts. Okay. Then the voltage in here, it will be from point A to point B. It should be minus capital letter B with the subscript AB, and this should be equal to 0. And if we try to simplify this one again, B sub AB is equal to 0. So if B sub AB is equal to 0, we cannot do anything. The reverse of that, the voltage from B to A will still be 0. So the same, B sub BA using solution number 1 is 0. B sub BA using solution number 2 by using the left loop, it's still 0. Okay, that's the solution, Mr. Veracruz. Okay. Where's my... Hold on. I'm getting my eraser. Actually, we could determine the voltage across point B and B by just inspection. Okay. Okay, I will try to erase this one. So we could visualize it. I would like to erase this one so we could visualize it. Okay. Mr. Veracruz is asking the voltage here, B sub BA. Okay. If you try to inspect the circuit, this is the ground of the first battery. This is the ground of the second battery. This is the ground of the second battery. And they are actually all connected here. Right? So it seems this point here is ground. But if we try to connect it, this is still a ground. So this is ground and ground. So actually, this point B and A are actually not different. They are the same. They are of the same polarity. That's why the reading is actually 0. And we have proven it that the voltage across this by using Kirchoff's voltage laws is actually 0. Because this is a ground and this is a ground. So if you put your resistor here, they are at the same potential, right? So the voltage will be equal to 0. That is by just inspection. I think this is a qualifying exam. Maybe I don't know where Mr. Veracruz got it. Okay, that's it, guys. So from the problem given to me by Mr. Veracruz, the voltage across B and A is actually 0. That's the first solution. Second solution is still 0. And by inspection, like what I said, this is ground and this is ground. So we are taking the voltage across the same terminal. Okay, so if we try to get the logic of that one, the voltage should be equal to 0. And we have proven it by placing Kirchoff's voltage law that the voltage across B sub B is 0. This is the second solution, B sub B equal to 0. Okay, good afternoon from Los Angeles. Thank you very much from Mr. Veracruz from Sri Lanka by sharing me this problem here. And I discuss it on my long video format discussion. Okay, good afternoon from Los Angeles.